Welcome again. My name is Matt Mickelborough from Junior Resource Investing. I'll be guest hosting this panel, which is titled A Deep Dive on Future-Facing Technology here in the metals and extraction industries. This is one that I personally am actually quite excited for. There's, I think, a lot of interesting technology and ideas that are being represented here. And in my research for this panel, I was getting pretty interested in the companies that are present. A couple of reminders here before I pass it off, though. This is being recorded, so just make sure that you understand that if you're participating or asking questions that may come up. And I will make sure to do my level best to make sure there's time for a question period at the end. So please get your questions into the chat. I'll be checking that periodically, and I'll do my best to get those to the executives here in front of you. Anyway, mining and resource extraction in general is one of humanity's oldest industries. Peoples, cultures, and empires for 10,000 years have had metals as a cornerstone of their livelihoods. But here, a quarter of the way through the 21st century, we have a complex modern world in need of modern solutions. This is because historical methods of metals use and resource extraction are understood now to have significant negative consequences. But despite these negative consequences, these industries remain as vital today as they were to our ancestors. Therefore, there is a clear, critical, emerging need for technologies that mitigate these negative consequences and allow for truly sustainable development. Joining me today are 4 companies with deep connections to cutting-edge technology and ideas in the mining industry, hoping to bridge this sustainability gap we are currently in. We are currently waiting for Julian Traeger to join us. I think he's just a couple minutes late, but should be on his way. He's the president and CEO of CoTec Holdings. Otherwise, present with us now are Joshua Grant, CFO at CVW CleanTech, Jean-Philippe Mai, who is president and CEO of Dundee Sustainable Technologies, and Mark Jarvis, CEO at Giga Metals. Thank you, gentlemen, for joining us today. How are you guys?
Good, Matt. Thank you.
Thank you.
Yeah, thanks, guys. Like I say, I look forward to this one. We'll start it nice and clean and easy. I'm just going to go left to right off my screen to start out. But company intros, who are you? Maybe a mission statement or governing philosophy that guides your company, specifically in terms of its approach to metals and resource-related technology. And I mean, basically, why are you relevant to this conversation today? So Joshua, why don't you lead us off?
Yeah, thanks, Matt. Thanks, everybody, for joining. So Joshua Grant, I'm the CFO at CVW CleanTech. We're a publicly traded company on the Venture Exchange under the symbol CVW, OTCQX symbol CVWFF. We are the world's first diversified clean technology royalty company. We will own a portfolio of technology royalties that will provide our investors with exposure to positive returns on underlying commodities that these technologies and our royalty partners recover. So our philosophy or vision statement, as you asked for, is to accelerate clean technologies that recover commodities in a sustainable manner that helps the world's decarbonization. So we've been a public company since approximately 2001. We spent 20 years developing our own 100% owned creating value from waste technology. In the summer of 2024, so this past summer, we announced that we would be diversifying into the clean technology royalty space. And to this effect, we closed our first royalty transaction in September 2024 for $14 million. Q3 2024 will be the first quarter where, as a company, to the best of my knowledge, we're earning fresh revenue. So an exciting quarter for our company and our shareholders. Thanks, Matt.
Thanks, Joshua. Jean-Philippe, off to you.
Yeah, great. Well, good morning. Hello, everyone. So I'm Jean-Philippe Mai. I'm the president and CEO of Dundee Sustainable Technologies. And at Dundee Technologies, we've been very active in the past 15 years at developing and now commercializing novel metallurgical processes for the mining industry. So specifically, we really focus on our development on addressing some of the challenges that our industry's been facing in terms of both environmental challenge, whether it's the use of cyanide or associated contaminants traveling with precious or base metal, and arsenic, which is a big contaminant in our industry. So these challenges were really what drove us to develop our proprietary metallurgical processes. So our first one is our Clever process, which is completely cyanide-free gold extraction process. And our second is our glass lock process, which is for the removal of stabilization of arsenic traveling and coming from mining operations. So We were fortunate to be part of the broader Dundee Corporation group, which has been supporting us over the years and allowed us to demonstrate at the industrial scale both of our processes. So we're now actively commercializing both of our processes and working with various actors within the mining industry to implement on-site and just really emphasize the environmental and the efficiency of novel metallurgical processes.
Thank you, Jean-Philippe. Over to you, Mark.
Okay, well, thank you very much, Michael. I'm CEO of Giga Metals, and we've got a giant low-grade sulfide nickel and cobalt deposit that we're developing in British Columbia. It's open pittable, and with our partner Mitsubishi Corp, we produced a pre-feasibility study about a year ago, and it modeled 30 years of production. In a typical year, it'd be about 35,000 tons a year of nickel and 2,000 tons a year of cobalt. So truly a giant project. There's lots of resources beyond the reserves that we've outlined in the study, and it's generally fairly low tech, except for one aspect. It's low tech in the sense of dig it out, crush it, grind it, froth flotation. It's all 100-year-old reliable technologies. It's a very simple circuit. It looks very similar in the mining and processing to a copper porphyry type of operation. The one difference is that our silicate tailings pile, and we've designed it as a large beach, small pond type of tailings management facility to expose a lot of the silicate sands to the atmosphere, because they will absorb CO2 directly from the atmosphere, and we can measure that. We can measure how much we're absorbing, and it'll work out to plus or minus 25,000 tons a year of carbon that's getting sequestered. So the silicate minerals convert into carbonate minerals, and basically the CO2 isn't stored as sequestered. It's turned into part of the mineral, and it's gone for geological timescales. So quite interesting, quite measurable. There's also a cementation process that happens, which will increase the security of the tailings management facility. So we're aiming to be part of the developing North American battery supply chain, although there's always stainless steel, which is still 65% of the nickel use, continues to grow. And that's us.
Thank you, Mark. And Julian, thank you for joining us here today. Just a recap for you. This is, you can probably infer, but company intros: who are you? Maybe a mission statement or governing philosophy behind your company and its approach to metals and resource-related technology.
Sure. Thanks, Matthew. And sorry to be slightly late. So CoTec is trying to answer the question, why isn't there an eBay or a Tesla of the mining sector? Why has the sector been somewhat immune to disruptive technologies thus far? Why haven't there been new entrants which completely transform the sector? And hopefully, we are the answer to that. It's a 10-year project. We're 3 years into it. The first 3 years was about identifying disruptive technologies and getting the rights to those. So we have announced 4. We have another 2 that we're documenting at the moment. The next couple of years is applying them to projects and showing that we can make it work at scale. And then the last couple of years is scaling the business. There are, we have a particular emphasis on waste. In Canada alone, there are 10,000 closed mines with tailings opportunities. I was in Australia 2 weeks ago for IMARC. Just in Queensland, there are 15,000 closed mines with tailings, and the liabilities for the states are in the trillions of dollars, and they can't deal with it. So recycling, reworking these opportunities is ultimately what we want to do. But we started off with identifying technologies. We looked at around 400 so far, and we've ended up with mainly process technologies in 3 areas, particularly initially iron ore, copper, and rare earth magnet recycling. And then within that, we are trying, like Jean-Philippe mentioned, to solve difficult problems like fines. How do you process fines efficiently? How do you process hard rocks efficiently? And so we have technologies to concentrate fines, to pelletize without heat, to leach low-grade copper deposits. So we have a technology like Jetty, but it seems to be effective in many more instances and much more quickly. And then, of course, we have a technology to explode hard rock with microwaves, because it's a metallic substance, a gravity separation technology for concentration. And then we have our hypermag technology, which can take spent magnets in the West, extract the rare earth mix, like a muffin mix, and then reuse that to make new magnets. And that's obviously super important given the issues with China and rare earths and magnets. So we're super excited about how we can create a responsible low carbon business which uses technology to really unlock assets which were previously considered to be liabilities.
No, excellent. Thank you, Julian. And the follow-up question here is largely an extension of that first question, but maybe a bit meatier. And this is where there's very interesting technologies present here. And I will encourage you guys to take some time to just showcase those to us. But Jean-Philippe, I'll ask this question to you first this time. Like I said, just please showcase your individual technologies, maybe in a bit more detail, and then demonstrate their importance as well.
Yeah, no, not a problem. And a lot of interesting comments, which maybe I'd like to comment on maybe as we proceed in our discussions. But
please do.
Just for our clever process, which was really the first technology which we started, it's the objective was really to develop an alternative to cyanidation for the gold processing. And what we do is we use a dilute solution of sodium hypochlorite with a catalytic amount of sodium hypobromite. So I don't want to bore anyone with deep chemistry here, but the fact is that we've all known historically that chloride is actually pretty good at fixing the gold, but bromide's even faster. So we're using the kinetics of the hypobromite to rapidly put gold into solution. When I say rapidly, typically within less than 1 hour contact time, we have gold in solution at the outlet of our leaching reactor. And we do this at ambient temperature and ambient pressure. So we're not using chlorine gas at high temperature like it was done in the past, where we're really using a dilute version of a household bleach like we all have at home. So we have about a 2% concentration of household bleach in acidic condition, which allows us to rapidly put gold into solution. And the key when you're operating a halogen circuit is we need to be closed loop in terms of our solution. So we recycle all of our solution using an electrolysis cell. So we have no tailings pond, so no liquid effluent leaving our circuit. So we're fully closed loop. So starting when you're developing a new gold process, people send you their worst material. So we've dealt with the worst of the worst, a lot of the very refractory gold ores, where very often that refractory component comes with the encapsulation of the gold within, say, an arsenopyrite sulfide structure. So when we were decomposing that arsenopyrite sulfide structure, we were left with an arsenic product which needed to be stabilized. And we weren't quite impressed with what the industry was doing in terms of arsenic stabilization. So this is really what drove us to develop our glass lock process for the stabilization of arsenic using vitrification. So the problem with arsenic is that it tends to volatilize at very low temperature. So what we've done is we're developing, and we use a compound which is stable at the melting temperature of glass, which allows us to incorporate high amount of arsenic within a glass matrix, which makes it insoluble and permanent from an environmental standpoint over long periods of time. So, but in saying this, we have nothing against clean oxide direct leaching material but very often, unless there's issues, people aren't looking for solutions. So we deal a lot and have developed quite a niche expertise dealing with complex material. But and as Julian said, I think that there's definitely an opportunity to leverage technology, efficient technology, to properly position yourselves in some of these deposits, which might be labeled as stranded or undervalued due to metallurgical or environmental challenges. So that's also a sandbox in which we play it. But to answer some quick questions on the comment, yes, there's our process could be an alternative for all of these deposits which have been previously denied the use of cyanide. But our objective here is really to work with developers, with miners, at really doing the work, setting up and doing the proper trade-offs so that efficient and good decision-making can be done for the future and the development of each project.
Excellent, Jean-Philippe. Thank you for that. I'll pass this over to Mark. Now, Mark, I'll just preface this a little bit. He's kind of a half step removed from the other gentlemen here who all represent technologies. Mark is represents a traditional nickel project, but nevertheless, obviously, nickel, is at the cutting edge in a number of reasons, or for a number of use cases. Sorry, that one threw me a bit. So, Mark, maybe the question will just, I'll massage it a bit for you. I mean, what emerging technologies or uses could you maybe enlighten us about with regard to nickel, whether that be extraction or end use cases?
Well, it's more about the end use cases with me. I'm a very interested observer in battery technology, which is rapidly evolving because batteries are appearing everywhere in our lives. And in fact, I'll just mention one end use that people I think underappreciate is robotics. I just think that you merge artificial intelligence with developments in robotics, and you're going to see a lot more robots in our lives, and they all require high energy density batteries, and so that's the key. And why I'm particularly interested, when you look at EVs, for example, there's two main battery types. One of which I love because it's nickel-rich chemistries. And the other is lithium iron phosphate batteries, LFPs, which have less energy density, but they've got many advantages. And in many EV cases, they're good enough. They supply good enough range. But nickel, and this is just background to a technology I want to talk about that I think is emerging in batteries. Nickel is got excellent energy density, and so if you want real range in your electric vehicle, you want to get as much nickel into your cathode as possible. The problem is, as energy density goes up, the volatility of the battery increases. You're basically making something that is more and more subject to what's called thermal runaway. So we've all seen videos of Teslas bursting into flames in the parking lot. It's quite scary. So the technology that I saw an announcement a couple of weeks ago, and it just sort of one of these quiet little stories that kind of drifts by and people don't notice, but I was absolutely riveted by it. This is LG Electronics, a research arm, and they've developed a membrane that goes between the cathode layer and the current collector in the battery. And this is a membrane that's a nanometer thick, and it's what the electrons pass through. But it's very sensitive to temperature, and so the resistance of this membrane goes up with temperature. And as the battery moves beyond the normal range, the resistance of the membrane goes up until it essentially shuts down the battery. It's just automatic, and it's quite striking. The electrical resistance increases by 5,000 ohms for every 1 degree centigrade rise in temperature above the normal range, and the maximum resistance is over 1,000 times higher than at normal temperatures. And then as the temperature comes down, it reverses again. So it'll get back to normal operation. And this was a paper that was out in the September edition of Nature Communications, which is a pretty significant scientific publication. And in an impact test on nickel, cobalt, manganese batteries for electric vehicles, a 10-kilogram weight was dropped onto the batteries, and all of the standard batteries caught fire. In contrast, 70% of the batteries equipped with a thermal runaway suppression material did not ignite at all, and the remaining 30% saw flames, but they were extinguished within seconds. That is crazy. That is awesome. That means that, essentially they have solved the thermal runaway problem, which means now battery makers are free to cram the nickel onto the cathode, increase the energy density, and increase range to almost whatever you want. And it makes me very happy because it's going to increase demand for nickel. LFP can't compete with nickel when it comes to range. It's an excellent technology in many ways, but it just can't compete with nickel for range. So I'm looking at that, and it's a quiet little development. LG thinks that it can be rapidly commercialized, and I'm very much looking forward to that.
Thank you, Mark. Julian, over to you, just to showcasing your individual technologies and importance.
Sure. Well, I think when we initially looked at our technologies, we didn't really want to do incremental things. So the things that are coming from Silicon Valley, like sensors or a better hydrogen truck, these are not really of interest to us. We were really interested in category killers where there was large scalability. So, for instance, if I go back to our magnet recycling business, we all know that magnets are necessary for some security applications like night goggles or missile guidance systems. But as AI becomes weaponized, I've become more aware of the fact that if we don't have enough magnets in the West, we're not going to have the disk drives to support the data centers, which are necessary to build the computing capacity in the battle between East and West. So, that's an obvious application where the Chinese, if they so wished, could completely slow down the growth of AI in the West very quickly. And these recycled magnets, for which there's already a pilot plant operating in the UK, the technology's had $100 million spent on it, is part of the answer to that problem. So that's a huge applicability, and we are talking to the major users of disk drives and computing power about this. And what's interesting about our technologies as a whole is that they're super green, they're much cheaper, they're much more modular. I think in the 21st century we are seeing, and we're going to see the benefits of economies of flexibility rather than economies of scale. There's a different way of applying these to traditional commodity extraction methods. But in addition, we have these other technologies like around iron ore to pelletize at ambient room temperature rather than the traditional induration 1200 degrees centigrade process, which we think is super exciting. We've spent years perfecting that, and now we are ready to commercialize that. And that, I think, there aren't going to be new induration pelletizing plants built anymore because of the heat implications. So this is the future, and it's a big market. So those are two examples, Matthew, of things we're doing. And it's all about trying to invent, a new way of extracting commodities in a super green and economic fashion.
Excellent, Julian. Thank you for that. Yeah, well articulated. And Joshua, I'll let you finish this one off.
Yeah, thanks, Matt. So we spent approximately $100 million in 20 years to progressively develop our technology to a TRL 8, or a technology readiness level of 8 on this TRL scale, 1 to 9, 9 being commercial production. So we're just on the precipice of commercialization. Our technology development, we've done large scale piloting. We've done successive commercial engineering studies. We've been successful in securing 20 active patents. In terms of the actual pots and pans, similar themes to what others on the panel have said. Very simple. In fact, over 90% of the equipment we have in our technology is equipment that's currently used on an oil sands mining site. So operators are very familiar with the technology. Physical separations, flotations, solvent extraction, distillation. So very, like as I said, simple technology, just using the pots and pans in a different way to come up with a different output or a different recipe. And we'll talk actually to some of the results or the outputs from our technology. So on an industry-wide basis, if through an industry-wide deployment, I should say, on an annual basis, we could recover up to 13.2 million barrels of hydrocarbons, so 11.4 million barrels of bitumen, and about 2 million barrels of solvent. We could produce up to 1.5 million tons per year of titanium and zircon concentrates. Those are critical minerals. This would satisfy about 15% of the world's demand for zircon and 8% of the world's demand for titanium, which currently is all just going to the oil sands tailings ponds. From an environmental perspective, we can abate up to 5 million tons of CO2 equivalents, primarily methane, and we can eliminate approximately 30,000 tons of VOCs or volatile organic compounds. So strong output in terms of commodities we can sell or commercialize. Strong environmental benefits. Per site, we can generate approximately 160 million to 260, somewhere between 160 to 260, depending on the site, $1 million of free cash flow on an annual basis. So really strong economics. And to put kind of the environmental benefits in perspective, we can abate over 90% of the methane that comes from an oil sands mining site, which would reduce their GHG profile by about 5 to 10%. Canada's GHG profile by 50 basis points. So that's the crux of our technology and the output that we can achieve from looking at our royalty pipeline. We've developed a pipeline of approximately $300 million of potential royalty transactions within 3 sectors we're looking at. We're looking at investing within the hydrocarbons, the minerals and metals, and the agriculture spaces. We intend to execute about 2 to 4 royalty transactions per annum, and deploying anywhere between $10 to $40 million per transaction, and successfully getting to larger amounts as we scale, right? And so that's how we believe we can bring positive diversification to our investors and accelerate cash flow generation.
Thank you, Joshua. Just approaching the midpoint here, and I'll just encourage people to get their questions in. A couple have come in, and I'll take this opportunity to remind people of that. Next question, almost kind of a flip side to the one that I just previously asked you to highlight your own technologies. I'll ask you maybe to just kind of cast your eyes outward from there, and as a sidebar, encourage you maybe to even interact or engage with other ideas or technologies present on the panel today. But aside from your own company, which aspects of the metals or resource sector do you think is most in need of innovation or disruption, and why? And Mark, I'll let you lead this one off.
Well, I think the whole idea of establishing a battery supply chain in North America has several serious flaws beyond, we need to develop new mines in North America. But, and then to process the raw materials into, cathode active materials, there's a few steps that we do not do in North America and that we need to start looking at. And I worry, frankly, about the permitting environment for some of them. So let's say you take our concentrate and you want to take a direct route to the battery cathode rather than take it to metal for stainless steel. You would put it through a pressure oxidation circuit. There are some of these in existence. There's one outside of Edmonton in Fort Saskatchewan run by Sherritt. There's Long Harbor, which is associated with Voisey's Bay. It's Vale. But there's certainly not enough of these pressure oxidation type refiners. They need to be built, and they would take our concentrate, and you could make it into mixed hydroxide precipitates. You could make it directly sulfate of nickel and cobalt. You can make it into briquettes. It depends what you put on the back end of the refinery. But the next step is what we don't have at all in North America, and that's to take sulfate and make it into a PCAM, precursor of cathode active materials. And one of the waste streams of this is, Epsom salts in large volumes. And so in Asia, they've got lots of PCAM facilities, and they're all sitting on the ocean, and Epsom salts are completely harmless. but you're adding more salt to the ocean. But we're not doing that in North America. And if you don't have PCAM facilities in North America, you're going to be taking probably MHP, shipping it to Asia or shipping it somewhere else, getting it converted into PCAM and then CAM material, and then shipping it back to North America. So that is a vital step in the battery supply chain we're not doing, and can't do it anywhere but on the ocean. You couldn't set up beside a river or a lake. You couldn't be pumping those volumes of salt into a river or a lake. It's something that governments, I don't think, are taking seriously enough or looking at seriously enough in terms of where would you put a PCAM facility, and where on the ocean would you put it, where you would do the least impact. So just want to highlight that.
It's the entire supply chain. No, excellent. Thank you, Mark. Julian, I'll let you take this one next.
Sure. I mean, we are interested in solving big problems. There are three we'd love to solve. If anybody knows of these technologies, we'd really like to look at them. So the first would be how to deradiate nuclear waste rapidly. We have seen one technology that claimed to do this, but the due diligence was very difficult. But that would be a big win, and particularly if you could release energy in that deradiation process. And these people said that they could do it quite quickly, and that would also unlock a whole lot of deposits which are contaminated by radiation as well at the moment and can't be used. So that's one we'd love to find. The second one would be useful uses for sequestered carbon. I think, taking carbon out of the atmosphere and then putting it back into the earth or injecting it is a very expensive process. It would be much better if we could find really useful end products which improved, the quality of life and civilization. So we need to think about that, not just sequestering, but actually utilizing. And then another one would be, which is a big problem, how to reprocess red mud. That's something that there's lots of that. It's a problem. How can we find a solution to that? Nothing's worked so far. People have been looking for decades. But these are three big process challenges that we'd love to solve. And it gives you an idea of, the ambition and the scale of what we're looking at in terms of how we choose things that are attractive. So hopefully that helps, Matthew.
No, excellent. Thank you, Julian. A couple quite interesting ones there. And so, yeah, Joshua, same question to you. Looking outside of CVW, what do you see kind of in need for disruption or innovation in the resource industries?
Yeah, thanks, Matt. I'd like to talk, I think, more about disruption than innovation. I think there are, some companies, such as CoTec, as Julian mentioned, trying to make big impacts. But as a company, we're focused on hitting singles and doubles with our royalties, and eventually those will turn into home runs. And obviously our proprietary technology is a potential home run. I think disruption is more utilizing our great Canadian innovation to our resources that we have in front of us, and we can make a big impact that way. So I'll talk disruption, and I'll talk specifically about circular economy opportunities, because right now what's happening is we're treating byproducts as waste, where they could actually be valuable feedstocks, right, for our existing production processes. So not necessarily just traditional waste rock or tailings, but if you think e-waste, right, e-waste is full of critical minerals that are essential for our existing production processes. And a lot of those times, those minerals or other inputs are already in its final form. So, they don't need to go through the whole refining process again. They've been manufactured once. They can be slightly recovered and reused. Construction waste is an example, right? Construction waste can be diverted to feed plants for energy, which is actually what's happening. What Lafarge is doing, they have 2 cement plants in Canada, and they're diverting construction waste. They're not just waste. Obviously, these don't have to be just waste streams. Spent tires or shingle recycling opportunities are other examples. And what I really like about spent industrial materials recycling is that, you might need to do some grinding or separating, some minor or shredding, some minor refining. But typically, you already have, as I mentioned, the mineral in the final form. You don't need to go to the mine face again, right? You don't need to perform the extractive activities, and often, 2 or 3 or 4 different mine faces, because everything you have around you is not made up of just one thing. So you don't need to do that. You don't need to go through extensive refining operations again. And so these plants, which are much more like manufacturing operations, they are much more compact and modular. And so they can be actually placed near urban centers where the waste is actually accumulating. So you're putting these plants close to where their feed is, which is not really where a lot of the primary production operations are. So I heard, funny analogy. I heard a waste recycling CEO refer to their model, or their scale-up model, as the Tim Hortons of waste recycling, where you could have one on every corner. And although I think that's a bit, unrealistic, it shows how modular these can be, right? And how they can be reproduced and scaled very quickly and efficiently. So circular economy opportunities is where I think a large opportunity lies.
I find it interesting. This is a quick interruption here on my part, but all three of you are kind of touching on or toying with the idea of onshoring more parts of our economy or industry in our own local jurisdictions. Jean-Philippe, last one to you. What's something you see in this industry that needs innovation or disruption in your eyes?
Yeah, no, I think very interesting comments from all of you fellow panelists, and maybe I'd just like to also comment that I think there's already a lot of very good technologies, within the mining metal space, and I think one of the issues is also the way we approach them from either developers or operators' perspective, and the lack of access sometimes to some of the technologies. A lot of projects or developers, if you want today to look at an alternative to cyanide for your project, where do you go, right? You go to the standard labs. All that they offer are bottle roll tests, but yet we're expecting, for people to be curious to look at alternative processes. The lack of access to a lot of those technologies is an issue, right? Unless you're very keen at looking at processes like us and finding us and contacting us, it's very difficult to do some comparison tests to even allow you to consider to then go through the extent of doing proper technical work to really look at the impact of an alternative recovery process on your project, because what we do, especially in our case, we're not a black box. People understand what we do, how our process works, but it really needs to be applied in the context of a project. We're not just $1 per ton, right? Our costs will be directly linked to the power costs, labor costs, site costs. So and to look at the overall benefit, you really need to do the work, right? It's not just a simple answer. You need to commit to really looking at how a new technology gets implemented on a dedicated project. And I think that's a barrier, because there's not a lot of direct offer to new technologies, although there's a lot of technologies out there that can solve a lot of the issues or at least be considered on solving a lot of the issues that we're facing today. So the model that our industry has creates barriers, whether it's through the standard lab facilities that do not offer anything else, or that we have to go through a lot of the engineering firms that sort of gate some of the processes or flow sheets that they might not be aware of, that other flow sheets have been applied, and there's other options. So there's several gates to go through for technologies to be seriously considered. So I consider this as some sort of barrier. And then, I hats off to Josh and Julian. You guys have a lot of technologies that you're pushing and wanting to develop. We have too, and it's not easy. We have industrial demonstration plants and yet it's, once you have one plant, two plant, people ask you, well, do you have a third one? It seems like it's never enough, right? So like de-risking and convincing and commercializing is very difficult. So we really need to have industry buy-in from the get-go to allow for companies and innovation and technologies to have a chance. Otherwise, a lot of very good ideas or good processes or good technologies might have died through the process because of how difficult it is to actually break that barrier and implement yourself as a de-risk and solid alternative to some of these conventional processes.
Matt, if I could add something quickly,
Please do.
Just to Jean-Philippe's answer, part of the commercialization process for clean technologies, part of the reality is we have benefits that impact many different stakeholders at our customers, right? And so we have, production or the ops team. We might have the environmental team, right? There might be an admin component to it. There may be a byproduct that the off-taker may or may not be interested in. And so, really getting past that goal line is one of the biggest challenges, I think, for our for technologies at the fully piloted stage, which it sounds like Jean-Philippe, you might have done one or two or maybe more of those. And so I think it's just recognizing early, how do you bring that lead, not necessarily a lead project manager on the customer side, but how do you bring the executives in so that they see the broader picture and they can support the final go, no-go decision with implementing the technology.
Just a quick point on this, Josh, you mentioned e-waste, circularity. For our process, we're focused on the minerals, but our process, due to the chemistry, applied very well to electronic waste. And actually, all of this year, we've been processing e-waste here at our plant. And it's a completely different industry, different business, different crowd, and people ask different questions, right? In the mineral space, directly is, what's your dollar per ton? But from an OEM, from a circular, from a recycling standpoint, people want to know, how do you do it, right? How do you handle all your plastic? How do you deal with your off gas? So it's a different approach, because there's a benefit to being able, from an OEM standpoint, to add a premium on a recycled metal, whereas it's very difficult to do on a mining and metals perspective. So I guess it's also some maybe an ideology, right, of people understanding a bit more of how things and how the process operates to see the overall value from a project perspective, right?
Yeah, I agree.
I think it's interesting, you two gentlemen, the thread that you're pulling on. It's not so much a technological need as it is a cultural one, where there's sort of commitment by industry to actually adopt these technologies and understanding what's actually already in existence for them to adopt. We're down to our final question here, and I'll let Julian lead this one. Maybe it is kind of a half step, maybe almost you could say that it's related to that last idea. But let's just talk financing, right? And that actual kind of rubber hits the road support for these technologies. Julian, who do you see in terms of companies or governments that are actually taking this sort of much needed innovation seriously by, not just, talking the talk, but walking the walk and providing funding or buying into them in some form?
Well, I think, on this subject, but more generally for our sector, the whole financing landscape has changed dramatically over the last couple of years. So I've never seen in my career such a split between what the insiders and knowledgeable, thinkers and major players think is important for our sector, and the general perception of retail investors and public market shareholders. And that dichotomy, I think, means that we need to think differently. And going forward, as I'm sure Mark will see with his business, our sector is becoming much more strategic, much more security focused. So there is lots of money actually, but it's money that's coming from, the U.S. Department of Defense grant program, or the Australian government or the Canadian government innovation program. There is money. There is new pools of capital in the Middle East, which are coming up as proxies for the West to secure strategic supplies of critical materials. I think we need to think differently. Obviously, there has been traditionally in the West quite a lot of money for university level R&D. So there has always been lots of great R&D coming out of the universities. I think what's been problematic is the capital to follow on and scale up, to the level at which Josh is now, and to commercialize that. There's been a sort of valley of death where a lot of technologies just have floundered. And that, I think, is an opportunity for new entrants to look at. But I think thinking that the retail investors are going to understand it and be there when they're not there for traditional mining, and even not so much even for gold in the current environment, means that we need to think, laterally and think differently. But I think the world is changing, and the major players, the strategic players, we're speaking to, I don't know, Apple, Microsoft, eBay, so on. Tesla, they are really interested. So I think you've got to put on a different set of thinking caps. But there is opportunities there, because what we're doing is very important, and what we're doing is actually inventing the future of the sector. And what we're doing is unlocking the enormous legacy that the West has in all the waste and e-waste and tailings, which we can use, and we urgently need to use to close the gap of critical minerals and increase our self-sufficiency over the coming decade. So it's super important, but unfortunately the public markets don't really get it yet.
Interesting, Julian. Josh, what about you? You're kind of in your own little space here on the panel in terms of where you are in the sector. What are your experiences at CBW in terms of access to capital, the willingness of government or industry or corporate companies to engage? And I guess maybe further to Julian's point, what in terms of retail or general investment sort of support or buy-in too?
Yeah, I'll shy away from discussing on the investor side, just because actually Julian mentioned a couple of things that I'd like to tease through a little bit more. Also, I'll talk about the funding environment from the private corporations, or private sector corporations, public or private. We have, I believe, earlier in their history, and Julian can correct me if I'm wrong, but CoTec was financing or looking to acquire rights to certain technologies that are now in the process of deploying. So similar but different to us. So we technically have two companies, if I'm not mistaken, on this panel who were, kind of in that financing ecosystem. We definitely are, and still are going forward. So I do believe that the funding ecosystem is maturing. Also, as Julian mentioned, I fully agree that there's a lot of capital available at the early stages. The R&D, whether it's through small scale grants, university funding, research funding, you have the SHRED credits in Canada, you have venture capital who are kind of looking for high risk, high reward opportunities. And then there's a dearth, and then there's a gap. And then once you've been operating for, call it 18 months or 2 years, you can get funding through BDC, possibly EDC. We're talking about the Canadian environment here. Or through a traditional bank if you're fortunate enough, depending on how de-risked your technology is, how many pilot plants you may have gone through. So where the lack of capital exists, and what part of our royalty model's thesis is based on, is for clean technologies in those early growth phases. So if you think about a baseball match in those early innings, where you have to really spend the capital to scale and build out your business, that's where there's a lack of capital available for technologies and operations in the clean technology space, and that's specifically where we want to play. So from an evaluation or decision-making perspective, we're looking for companies that have been significantly de-risked, technologies, I should say, that have been significantly de-risked. So significant piloting or some actual operating experience. From a commercial perspective, Julian also mentioned strategics. So if there's strategics in there, that makes us comfortable that they've done their due diligence, right? They've validated either the feed or the offtake, depending on what side of the equation they're on. So we're looking for a significant percentage of the feed to be under contract. Excuse me, the feed and the offtake to be under contract. So if you think of it as like a mousetrap, to be the feed under contract to keep the mousetrap fed, and then make sure there's an actual market for the end output for our royalty partners. So we're not creating a whole new market. We are addressing a current market and a current need. The reception we've received so far has been quite strong. Immediately after we announced our first transaction in the summer and our royalty strategy, we had, call it 5 technologies and companies reach out to us for consideration. And so if you think about what drives a technology operator to want to what motivates them, it's really the passion for their technology and seeing it scaled and deployed as far and wide as possible, versus a traditional mining royalty company where that executive team is bullish on the commodity. They really believe in the commodity. They don't want to give you the upside if we were a mining royalty company. But as a clean technology royalty company, if we can provide financing to technologies and operators in the early innings of their journey, to advance their growth by 12 to 18 months, that's really valuable for them. So we found operators pretty receptive.
Excellent, Joshua. Jean-Philippe, any thoughts on this one?
Well, many thoughts, but I'd definitely like to echo Julian and Josh's comment. Obviously, being a Canadian company, we're in that ecosystem where there's a lot of early capital available, which we benefited, over the years from the different programs. And sometimes in terms of funding, you have to fall within that box, right? Now are we critical? We're not critical. So there's really some boxes that sometimes we need to fall into, but we've been very fortunate also from the public funding, but also from having good supporters that allowed us to operate and to demonstrate at the industrial scale. And then, a point that you mentioned, Josh, is having strong feed supply suppliers and off-takers to really cover the whole spectrum of the technology value chain, where unfortunately sometimes we're very focused on one aspect. It's already difficult to develop and to operate new technologies, that it's also difficult to have feed guarantee that justifies the construction and operation of your plant, when, as in the metal space, it's very difficult to have terms that are over a year in terms of visual, because no one wants to commit too far down the line in terms of feed provisioning. So it's really finding the right partners, the right collaborators, but also looking at where do we add the most value from a technology point, and being ready to take equity position and to position yourself where you control the decision timeline much better, and allow to access for better funding, because you do control both the downstream and feed, and really allow to leverage your technology to create maximum value here.
No, well put. And Mark, final thoughts on this one?
Well, from our perspective, it's all about the strategic investors. So we created a structure when we entered into a partnership with Mitsubishi Corp, where we've got a joint venture company that they bought 15% of. And then they're now partners. And as we develop this, they've got to pay their share as we continue development. And that's a model that we're working on finding new investors to come into. Mitsubishi never wants to build a mine or operate a mine. They want to have a minority interest. They want to help get it built. And ultimately, they want as much of the offtake as they can get. So it's an interesting landscape right now, because, a year and a half ago, I would have guessed that the most likely next investor would have been an OEM, a car company. They were all very keen. And we've been talking to car companies, battery companies, as well as mining companies. When I look at the automobile industry today, Michael, I just think it'll be a miracle if the Western car manufacturers survive, honestly. China is coming to get them. And China already owns the raw material supply chain to make EVs. They own it, you know, everything from rare earths to nickel to lithium. I mean, they've got everything they need. They're backed by cheap capital from government-controlled banks. And so, you know, they can develop assets that aren't even particularly economic. You know, people think that Indonesia is like cheap nickel. It's not cheap, at least not the stuff that goes to the battery supply chain. It's just very well financed and very well backed. So, but as I say, a year and a half ago, we were in some pretty interesting discussions with car companies who were engaged in, I would call, irrational exuberance at the time. They all jumped into the EV space at the same time. They made too many cars, very expensive cars, and they couldn't sell them enough. And they're losing billions on their EV divisions, and now they're all freaked out and running away. I think they'll be back, because if they don't come back, if they don't replicate what the Chinese have done, I just think 10 years, 20 years from now, if they exist at all, they're going to be small niche remnants of what they are now, perhaps luxury, you know, automobiles, that sort of thing, but very small remnants of what they are now. Currently, we're talking to, we've got active discussions going on with mining companies and battery companies, because there's, well, put it this way, we've got 2 discussions underway that I would call sort of enthusiastic discussions. And that's what it's all about to us, is getting that next strategic investor into the fold. And so stay tuned.
Gentlemen, I think that's the end of my planned questions here. The timing has been pretty darn good here with this 3 minutes to spare. I want to thank you all. I thought this was a very kind of in-depth and articulate conversation. 4 intelligent guys here joined me. Only one question from the audience, such as it is right now, and I'll, a slight delay here, giving people opportunities to jump in. But this one here from Robert Tremblay. This is for Jean-Philippe. So this is a question on Gabriel Resources. There's massive issues for Gabriel Resources in Romania to get their gold project approved by the government. It requires arsenic to extract the gold, and the government wants no part of it. I mean, I guess the obvious question is, can clever technology resolve this to go forward? And maybe even more, tiptoeing into potentially material conversations here, but, are you in contact with Gabriel Resources? Are you aware of your technology? Anything on that front that you can provide for us, Jean-Philippe?
Well, short answer, I'm aware of Gabriel Resources. It's been, it's now more of a legal battle over the previous year, but that's a typical example where there's a developer that was denied a cyanide permit. So again, having looked or at least investigated alternatives, as the project we're developing, we would have been maybe more nimble and flexible on providing alternatives to instead of just a single set way forward, which in this case was cyanide. So technically, Clever is definitely an alternative. Now it's bringing the flow sheet and the use of Clever up to the level of a feasibility or ready for applying the permit type of project. So there's a lot of parallel work that needs to be done. But technically, Clever is an option, is an alternative. Yes.
Thank you. And one just snuck in here under the gun here, just 2 minutes here from Peter for Julian. Julian, can you please comment on the U.S. and or the Canadian government turnaround time on funding packages? Seems like it can take 12 to 24 months to apply, get a loan commitment, and then close on the loan or grant. Any thoughts on that one?
Well, I mean, I don't think it. I mean, it can obviously take a long period of time. I mean, we are in various processes which are more rapid than that. But, I think we'll see with Mr. Musk's efficiency drive whether those time periods get truncated. I think everything could change now with the US and we'll see if we have more project warp speeds like we did during the COVID era. But there's a lot of money to be obtained there. So.
No, excellent. Well, I think I'll call it there, gents. We are officially done on our time. So, yeah, thank you, gentlemen, for your time today. And thank you for, like I say, a well-articulated conversation. Please head over to Joshua Grant from CBW, Jean-Philippe from Dundee Sustainability, Mark Jarvis from Giga Metals, and Julian Traeger from CoTec Holdings. Thank you, guys, and we'll speak again soon.
Thank you, Matt.
Well, thank you very much, Matthew, and pleasure meeting all you guys.
Thanks, everybody.
Absolutely. See you soon. Bye.
Bye.